Last time I used AI to generate my anime wife. This time I actually tried using it to assist me with some tasks. For starters, I wish I knew more about how AI actually works. By that, I mean the nitty and gritty of the network architectures, how tokens are calculated, you know, the nasty mathy stuff. But when I need a TLDR explanation, I typically enjoy watching computer file videos. So when they released a vid on Deepseek, I knew I had to check it out. I started out with a legacy test bench, a Proxmox server with 4 NVIDIA M6000 Quadro GPUs, 12 GB of VRAM each. They are not interconnected in any way. I've created a VM with a single GPU assigned to it. Following NVIDIA's guide, I installed CUDA toolkit and drivers. After I confirmed with NVIDIA SMI that GPU is properly detected, I installed Llama and, well, I made a lucky guess and downloaded the Deepseek R1 32 billion parameter version. To my surprise, it actually ran, albeit very slow. I may have brushed past everything super fast, but trying out AI for yourself is actually super easy. Granted, you have CUDA toolkit and NVIDIA drivers installed. With Llama, everything is pretty much automated and streamlined. It's perfect if you just want to play around. In my case, installing CUDA toolkit and drivers is pretty simple. Look at those instructions from NVIDIA's website. Literally install the toolkit and then choose your drivers. If one doesn't work, apt uninstall it and then apt install the other one. Anyway, I made the Deepseek faster by adding more GPUs. I wasn't expecting this to work, but the model actually scaled out and utilized all of the GPUs, which gave me a significant speed boost. I'm not quite sure how this mechanism works, but it's worth knowing. On a live stream, I've tested 2 types of prompts with 2 versions of Deepseek, the smallest 1.5 billion parameters and the 32 billion parameters one. My first prompt was for the model to suggest some server configurations for small business. It's worth noting that at this point the Deepseek utilizes something called chain of thoughts, and by default you can see it when running the model locally. I have to say, it's more interesting to follow the reasoning process rather than just analyzing the answer. The model sadly hallucinated some information about server models, but overall 32B came out with some useful hindsights, and smallest one completely made up the details, but still had somewhat reasonable pointers. I also thought that comparing the 32B to the 1.5B, the chain of thought is somewhat more caveman-like in the smaller model. For the second prompt, I asked the Deepseek to generate some text, but to present the results as base64 encoded string. I noticed that Deepseek tries to avoid performing tasks like this and gives you a list of steps to do it by yourself in Python, so it needed a little more incentive. And so it actually gave me a proper base64 string. It even managed to decode without errors into something. Sadly, the result was gibberish, but at least it wasn't binary data, but an actual ASCII text. After that, I tried running 70 billion parameter model on NVIDIA V100s. No major surprises here. The 70 billion started and was a bit more knowledgeable about the world. So, judging just by the size of the model, it has more knowledge built into it, but the thought process is still impressive. While smaller models may know less about the world, they still can perform useful data analysis if supplied with data in the query. One funny example of the hallucination and lack of the knowledge was when the 1.5 billion model suggested me a server with AMD i9 CPUs. So finally I gave Deepseek a run for its money. It's nothing impressive, but I asked it to help me with building a front-end for my transcribing app. Basically, I have a Whisper model running, which handles the audio-to-text transformation, but I really needed some simple web interface. For this, I tried the public instance of Deepseek, not the self-hosted one I have, just so you know. And I did this because I really wanted to have full coverage of every size of the model. And just so you know, by default, I didn't see the chain of thought in the public one. First version of the app I was presented with was done in Python using Flask and template rendering. I had a proof of concept app within 30 minutes. It accepted audio files, saved them on a server, and then passed them to locally running Whisper instance using HTTP post. The most important thing is that it ran without any errors. Well, granted, you still had to read it to input the missing variables like the Whisper API, IP or host name, but still, it ran without any errors just as I asked it to. Since I wanted to share this app with my coworkers, I asked Deepseek to improve everything by adding asynchronous task processing. It took the previous design and improved it by including a salary-based task manager. Now the user gets the result in a more robust way instead of doing everything within a single HTTP request with a very long waiting time. With that scaffolding done, I spent over an hour modifying and tweaking it. The final product transcribes audio and allows users to download the text and an SRT subtitles file. It basically made the subtitle generation instantaneous because it provided timecodes needed for the subtitle segments. I can almost guarantee you that my next video will be on that project alone because I've heard your feedback on Discord and other platforms, but I still need to flesh out some details. Being able to see the chain of thought is an amazing feature, more important than the query responses by itself, in my opinion. Very often following it might make you realize you haven't looked at the problem from all possible points of view. For example, when trying to come up with server configurations, even the smallest Deepseek models were asking themselves whether they should suggest tower or rack servers because the server might be under somebody's desk, because small businesses are often located in small offices or even homes. I like how it could take a really realistic, down-to-earth approach to some problems and realize its own limitations. Having done those simple tasks, I am tempted to incorporate AI more in my day-to-day tasks, with big asterisk, as long as I can easily run them locally without expensive server to power it. And Deepseek seems to match this criteria, at least for now. Next time, we're building voice-to-text AI self-hosted service. Until then,